Hello, as promised, we are going to work out a question based on hypothesis testing when n is large, and we're going to be moving away from a binomial distribution to a normal distribution to carry out our hypothesis testing. Now, it is believed that a particular die is in favor of a 6. All right, so the die is rolled 80 times, and a 6 is obtained 25 times. We need to test at 5% level of significance whether the belief is justified. Now, first of all, I'm going to let x equal number of sixes, okay, obtained after the die is rolled 80 times. And so we're looking at, if it's in favor of 6, we have a probability of success that probability of getting a 6 is going to be 1 over 6. All right, so we're looking at the binomial distribution because there's a probability of success and a failure and a limited number of trials, which is 80. However, 80 is very large. We're going to come to that in just a moment. So x is binomially distributed with n, which is 80, and p. Sorry. Now, because we're moving away, we know that this is 80. And if we were to take 1 over 6 times 80, we're going to get a value which is greater than 5. And even if we take 80 times times 5 over 6 is going to even though be greater than 5. So we're going to move away from this binomial distribution. So now we're going to approximate to a normal distribution. Approximate to a normal distribution. So for a normal distribution, I need my mean. So x is now normally distributed. Mean is going to be equal to np because we know that e of x, which is the mean, is equal to np, and all of that is equal to 80 multiplied by 1 over 6. That gives me 40 over 3. So my mean is now 40 over 3, and my variance of x, which is npq, so that's going to be 80 times 1 over 6 times 5 over 6. 40 over 3 times 5 over 6 is 100 over 9. So that's my variance. So if my variance of x is 100 over 9, then the standard deviation is 10 over 3 to the square. So let's see. This is my parameter for the normal distribution. And what do we do from here? We may have to calculate this. So we're testing basically now at 5% significance level. So what does 5% significance level entails? We have what we're going to define now, a null hypothesis. A null hypothesis is that HO is such that P is equal to 1 over 6. And the alternative hypothesis, H1, is such that P is greater than 1 over 6 because it's in favor of a 6, therefore it could only be greater, it can't be less. Right. And from here, we have to test at 5% significance level. So we're looking at the right-hand side. It is one-tail situation, one-tail test. One-tail test. So that means I'm looking at the right-hand side because it's greater. And what is this value of z here? Right, so 5%, if you were to check this in your calculator, you'll get the z value here. So 1 minus the phi of z is equal to 0.05. So z is going to equal to phi inverse of 0.05, which is 1.645, I suppose. Let me just check it out from my calculator. From the table. 1, so we're looking at 0, 1, 0, I mean, so hang on, 1 minus 0 point, this is, okay, 1 minus, it's going to be 0.95, so 0.95 is 1.645. So we're getting this from the table here, all right? So here we are. So now we know that this value here is going to be 1.645. And now, because we've approximated to a normal distribution, we need to apply the continuity correction. And before we do that, we're looking for probability of x is equal to 25. Because S6 is obtained 25 times, so probability of x equal to 25. So then I'm going to say this is then probability of z. Can I say 24.5 minus 40 over 3 divided by the square root of the variance, which is the standard deviation, 10 over 3, and then minus less than, okay, so this is less than z, okay, and then less than 25.5, because I'm applying the 0.5 comes into perspective here because I'm applying by continuity correction. So after applying continuity correction, this 25 will turn into 24.5, 25.5, minus 40 over 3, and all of that over the standard deviation, 10 over 3. So if I put x as 24.5, I'm going to get this. My z value is going to be equal to all of that, 24.5 minus 40 over 3 divided by 10 over 3, which is then 3.35. Okay, so we just do that. Right, so this is correct, 3.35. And now if I put x is equal to 25.5, I'm going to get a second value of z, and that's going to be 25.5 minus 40 over 3, all of that divided by 10 over 3, and this comes to 3.65. These two values are those two values here. When we look at the diagram over here, the normal distribution curve, this value 3.35 and 3.65, both of these values fall in the critical region. And because I know that this is my HO and this is my H1, and these two values here, they fall somewhere there, over here one, over here another one. So those are the two values, 3.35, 3.65. So 3.35, 3.65 falls here actually. So now this is in the critical region, as you can see there. And therefore, what happens is we reject HO. So we're not accepting that this is 1 over 6. We're accepting H1 in favor of HO. So what we're saying is that then HO is rejected in favor of H1. So we're accepting H1. We're saying that the die is in favor of 6. We're accepting H1 here. We're accepting this. So therefore, we conclude, okay, it is concluded the die is in favor of a 6. So that's the final answer to this question. I hope that this has been quite illustrious in terms of understanding how we actually carry out a hypothesis test when it comes to a sample size being very large and therefore moving away from a binomial distribution to a normal distribution. I thank you for your attention. Take care.